A stamp 2 centimeters tall is being held 7 centimeters from a lens that has a focal length of 5.5 centimeters, a converging lens. Where is the image located? What kind of image is it? Is it right side up or upside down? How tall is the image? We're going to solve this two ways, by drawing a ray tracing diagram and with calculations. As you can see here, we've got the principal axis already drawn, and the lens and the focal points are already marked. And there's our object, 4 blocks tall, where a scale of 1 block is half a centimeter. We're going to start off by drawing our principal rays, and here is the parallel focus ray. There's the parallel part, and here is the focus part. Now I'm going far beyond the edge here because I expect the image to be far to the right, because the object is outside the focal point, but it's pretty close to the focal point. Here comes the central ray. And now I'm zooming out so that we can see the whole diagram here. And now the focus parallel ray. There's the focus part, and that converging lens is bending the ray toward the axis. And I messed up that part, it wasn't quite horizontal. And there we go. And I'm going to redraw the central part, the central ray, because it wasn't quite long enough. And I'm making sure that it is crossing the center of the lens, not trying to line it up specifically over there on the right, but making sure it crosses in the center of the lens. And then hopefully on the right they all cross at the same spot. My principal axis isn't quite long enough, so I'm going to extend that. And then draw where the where the image is located. There is our image. It is upside down. It is larger than the object, so the magnification, well, the magnification will be negative, but in absolute value it will be greater than 1. DI, counting the blocks to where the image is and using the scale, I'm estimating is about 24.7 centimeters away from the lens. It was a little bit more than 49 blocks. And counting the blocks to find the height of the image, and again using the scale, 1 block is half a centimeter, it's about 7 centimeters high. And upside down, so I put a minus sign on it. This is a real image. The rays really are crossing here. And of course it's upside down. So we've answered all the questions. Now let's go ahead and redo the same problem using the thin lens equation. Part B. One over f equals 1 over dO plus 1 over di. And therefore 1 over di is equal to 1 over f minus 1 over do. Our f here was 7 centimeters. Oh, sorry, the f was 5.5 centimeters, and do was 7 centimeters. Pulling up the calculator, 1 over 5.5 minus 1 over 7 equals that. And remember, that's 1 over di, so we need to take the inverse of that to find that di is 25.7 centimeters. That compares pretty well with the 24.7 centimeters from the drawing and 25.7 centimeters for the calculation. We're going to believe the calculation more because you can see from the drawing that a tiny difference, being off just a little bit in how you draw those lines, with that shallow angle there, really can make a very large difference. In this case, about 2 blocks worth on the graph paper. 1 centimeter's worth. And now for the magnification. Magnification is negative di over do. So it gives us negative 25.7 centimeters divided by negative 7. Gives us about 3.1. Or 3.67 rather, as our magnification, and therefore, and that would be negative 3.67, and therefore our height of the image is a magnification times the height of the object. The height of the object was 2 centimeters, so that gives us 7.3 centimeters as the height of our image.